In this video, we're asked to write a sum method for our public class entry. And in the sum method, what it really does is we're going to take the data values and we're going to add them up. And then we're going to return the addition of all of the values together. So once again, our return type, because we're returning values here, our type is going to be of integer. And yeah, so public int sum, because we're dealing, this is our public class, we don't want to pass in any parameters because we want to make this look as simple as possible. So what we're going to do is we're going to call upon our private helper method, and like the other methods before, we're going to pass in the overall root that we're looking at. So our private helper method should also be of the type integer, and like before, it's going to take an int tree node as the parameter, and we're going to call this root. So once again, we do have to deal with a base case. So our base case so happens to be, okay, what if we have no roots? Well, then in that case, we're just going to return 0 because we have nothing to look at. So let's look at it. If root equal null, then return 0. Do we have a special case? Like, well, in this case, we don't have a special case because if there is a root in general, it doesn't matter as to whether or not it has a right or a left side, or if it has both or not. We just want to look at the total number of data values in general, and that's going to be given to us with each individual leaf. So we're just going to deal with an else case here. And what do we want to do in this? Well, we want to return the root.data, because at this point we know that if we miss the if statement, then we know we have a root and we want to access its data point. Then what we want to do is we want to call upon our method to look down the left side of that root if there's one, and then we want to look down the right side of the node if there's a right side to that. If there's no right side and if there's no left side, then we'll actually hit this point where the root is equal to null, because we don't have any further paths to travel down. And that's the solution to this problem. See you guys in the next video.